that's new. Okay. So this was actually earlier. Hope this all kind of looks familiar to you. Again, I wouldn't you can watch this recording and grab it, but you should already have this in your notes. Because I'm going to remind you that when we were in here the other day, Monday, we talked about how if you have a formula for a compound, you can use the periodic table to find out how much it weighs in AMUs, a molecular or formula unit. And you can also, once you have that number, you also have the molar mass. So the molecular weight of the formula weight are in AMUs. Molar mass are in grams per mole of that substance. This is for the elements. And so once you have molar mass, for instance, calcium, you just look at the decimal number for calcium. It's 40.08. You got the molar mass. Once you have the molar mass, we can use it to work problems. In this case, we're going from grams to moles. Okay, so that's kind of where we're at. So stepping forward then, we're going to use those molar masses that we talked about on Monday. Use the decimal number for each element, the periodic table, to come up with how much it weighs in AMUs, and that is the same numeric number as its molar mass, but you have to change it to grams per mole. So remember, the thing in square brackets probably won't be in the problem. So you probably would read how many moles is 1.28 grams of this compound. So you're given the mass, you're trying to get to moles. So I need to see you do this part. Okay? So I'm going to even emphasize that. And sometimes students say, what if you get the right answer? Well, it doesn't work. I mean, it doesn't make a difference. You have to show you have to show this stuff. I was talking to my husband, who also teaches this class, and I said, I tell them if you put it in your calculator, you have to write it down. He's like, but sometimes there are things that you use in your problem that you can do in your head. And even those things you do in your head, you need to write down and communicate. Okay? Is there any questions about where this came from? This is like what we did last on Monday. Okay. So I'm going to go ahead and unpack up in that corner there what this means. Okay, what 119.37 grams per mole means is that just for this compound, there are 119.37 grams of CHCl3 per 1 mole, that compound. That's what that means. I should never in a problem see G/MOL. I should never in a problem see G/ML. Okay. So, all right. So we'll work this problem. I need to see that in the margins. Okay. And then to work this problem, we go back to the information that was given. We're converting 1.28 grams to moles. So our first term is going to be that 1.28 grams. So do you see, I want grams to cancel, so I'm going to put grams down here. So this is where my 119.37 grams is going to go. I'm going to put 1 mole up there. That's it. Okay, grams to moles. How do we do it? We used its molar mass of a compound. How do you get the molar mass of a compound? Well, you have to have a periodic table handy, and you have to add up the mass brought to the table by each element. So, fingers up. How many sig figs? I'm liking it. 3. And why is it 3? Because of this guy right here. Does that make sense? Okay, so then we're done. So again, so do you see where this is 3 sig figs? This is where sometimes students kind of want to do otherwise. But this first 0 right here, this one, we have to put it there to kind of put perspective on the number 107. 107 is a decimal, and it begins in the hundredths place. Okay? And this 0 is significant because it's between 2 numbers that aren't 0. Cool. Okay. So that was a mass to moles. Let's do a moles to mass problem. Okay, you guys are going to be able to do these in your sleep. So again, since it's a compound, what we have to do on the front end is knock out its molar mass. Okay, so you'll have a periodic table. You can look up the decimal number for carbon, the decimal number for hydrogen. Okay, so I need to see, you can see on the next slide, I need to see you do this work. Okay. And I love the concept of a molar mass. The mass you need to set aside to get 1 mole of those repeating, let's see, it's got carbon and hydrogen, looks like a molecular compound. 1 mole of those molecules. You need 16.04 grams. Okay, so in my margin, I would even unpack it 16.04 G over 1 MOL. Okay, so the first term is going to be that 0.444 moles. Maybe. There it goes. Oops, that really went backwards. So the first term is going to be that 0.444 moles. And this is the molar mass, isn't it? The second term is the molar mass. Let your units do the work here. So I haven't been crossing them out, but see, the beauty of this is that this is over 1. Okay, these units of moles cancel with these units of moles. And we're left with units of grams. Voila! And you can already see how we need to round our answer to 4 significant figures, because honestly, there's 4 significant figures in both of these terms. Both the moles that we wanted to convert to mass and the molar mass. There's uncertainty, there's wiggle room in the molar mass. Cool. Okay. So one more twist on the whole finding moles problem. I guess we could do it the other way around too. But the twist is that, let's just say we didn't want moles of molecules. We wanted moles of cute little atoms, little bromine atoms. Okay. So we're going to go from mass, 1.92 grams, to moles. Okay, but we don't want moles of CH4. We don't want moles of CBr4. We want moles of bromine atoms. Okay. So, given the formula of the compound, it's just like given the formula H2O of water, 2 hydrogens, 1 oxygen. CBr4, 1 carbon, 4 bromine. Most of us are good with this kind of on a molecule scale. We have 1 carbon and 4 bromine. Okay, if I were to ask you if you had a dozen CBr4 units, 12, if you had 12 of them, can you see where you'd have 12 carbons and, let's see, 12 times 48, or sorry, 12 times 4, 48 bromine atoms? Are we good with that? In other words, if you had a dozen CBr4 molecules, you would have 1 dozen carbon atoms and 4 dozen bromine atoms. Okay? So here we go. That formula of telling you the relative numbers of atoms in 1 molecule of CBr4, we can scale that up. Instead of a dozen, we can use mole. So there's an important little ratio that we're going to end up using. Just from the formula of the compound, we could say that in 1 mole of CBr4, there are 4 moles of bromine atoms, scaling it up from a dozen. In 1 dozen CBr4 units, we have 4 dozen Br units. Why? Because they're like that, okay? So now just to kind of tell you what we're going to do on the next slide, we were given the mass, okay, I think it's like 1.92 grams. Okay, we're going to go from the mass of the compound, okay, and we're going to go to the moles of the compound. And that's normal, what we've been doing, right? In the margins, we're going to have to look at the decimal number for carbon, take it times 1, plus look at the decimal number for bromine, take it times 4 to get that. Okay, so over this arrow I could put MM stands for molar mass of the compound. Well, once we have the moles of CBr4, we can go to moles of cute little bromine atoms using, dun 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 dun, that ratio. Okay, by that time, can you see in the numerator we're going to have moles in the top of the numerator, we're going to have moles of the compound. And do you see if we stick this in there, moles of the compound are going to cancel, and we're going to be left with moles of bromine atoms. Okay, so I'm going to do it all in one fell swoop, but it could be broken up. Okay, so we're going to go to moles. We aren't going to go straight to moles of bromine atoms. First, we're going to go to moles of compound. We need the molar mass of the compound. So decimal number for carbon, you're probably going to eventually memorize. Okay, 12.01. The decimal number for bromine, 79.90. Getting kind of heavy there. So you've got to show this. Notice that I've given 5 significant figures for the molar mass. And honestly, it kind of comes about naturally and honestly because those numbers of 1 and 4 respectively are exact. There's no uncertainty in the 1 carbon atom and the 4 bromine atoms. There is uncertainty in the decimal number for carbon and bromine. But then we're kind of adding. So basically, you end up with 2 decimals from the carbon term, 2 decimals for the bromine term. So actually, it's all legit. So your last order of operation is to add and you round according to decimals. Okay, so I would, if I was doing this up in the corner, write 331.61 grams of, now I might be explicit this time. I'll go ahead and say what I would do. I would put the molar mass, I would unpack it so I can use it, 331.61 grams of CBr4 per 1 mole of CBr4. I probably would do that. So then, working the problem, I told you the strategy was to start with the mass of the compound, use the compound's molar mass to get to moles of the compound. So we'd probably put this over 1. And we want grams of the compound to cancel. We want to be left with moles of the compound. So do you see where we're using what I call as the flipped version of the molar mass? This is going to be 331.61 grams of compound, 1 mole of compound up there. Okay. So now we're kind of bringing in the ratio you saw in the bottom right-hand corner, okay, where we said that there are 4 moles of bromine atoms for every 1 mole of CBr4. So the beauty of this is if we look kind of from left to right at what units cancel, mass of the compound cancels, moles of the compound cancel, okay, and we're left with moles of bromine atoms, unit-wise. So get your fingers ready. How many significant figures? I'm liking it, 3. Yep, very good. And what would the units be? Moles bromine, you got it. So you guys told me 3 significant figures. Remember that this 0 right here, actually both of these zeros, some students, I think the convention now is if you have a number that's less than 1, you put a 0 before the decimal. Okay, and this is not significant, so there's 3 sig figs. Good stuff. Okay, whoops. So I brought my book here for this review session afterwards. I'm going to kind of sit. Today's review session is not going to be in that little room, that cute little room. We have it reserved for Wednesdays after this, but this Wednesday somebody else had it. So there's like kind of around the corner library, and we can be as noisy as we want, or you can. There are some tables kind of around back there. We're going to kind of park it over there. And I think I'm going to be at a table over here, and you guys can, so I might kind of grab the binder for the assigned problems. But so these will be due on Friday, and I did not take a look at them yet, but how hard could they be, right? These will be due on Friday. Uh, 3, 7, 8. 7 basically gives you the formula of a compound, and you're supposed to give its molecular mass. You can use that if you have do that if you have a periodic table. The second part is you're supposed to, with that formula, and this particular formula says that for every repeating unit there are 11 atoms of hydrogen. That's the little subscript of hydrogen. It wants to know how many hydrogen atoms per mole of the compound. I think you'll do great. Number 8. So you know how sometimes they do pairs, 7 and 8. 7 you got the answers for, 8 you don't, but they're very similar. 11 and 12. Yep. I mean, that's all just stuff we talked about just today. Okay, kind of Monday and today. So here's the deal.